engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
questions,
Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to the Naked Scientists podcast, the programme that brings you the biggest breakthroughs in science, technology and medicine. I'm Chris Smith, and this week we are delving into the science that Einstein dubbed spooky action at a distance. It is the quantum realm, and my guest is the award-winning physicist and science populariser, Paul Davies. Titans of Science is all about showcasing science superstars making huge breakthroughs and giant leaps forward in their scientific realms, and this episode is no exception, except that the subject matter demands this time that we turn that telescope around to consider the extremely strange effects that kick in when physics shrinks down to the atomic scale. We are, of course, taking a tour through the world of quantum mechanics, and our guide is the physicist, writer and broadcaster Paul Davies. Now, more about him in a second, but first to give you a flavour for why the subject he studies even baffled Einstein. Consider this. If you take a strip of paper and cut two vertical slits in it, side by side, and shine light through them, like waves washing into the entrances of a harbour, behind each slit you see a pattern of rings, and where those rings overlap and the waves either add together or cancel out, you see bright or dark patches respectively. So what happens if, instead of doing this with light waves, you instead use particles, like electrons or even whole atoms? Well, logic says that a particle would have to go through one or the other slit. It can't be in two places at once, so you wouldn't get that same pattern. But you do. In other words, the atom, or the electron, must have gone through both slits at the same time, mustn't it? Yes, I warned you this was weird, but stay with me because it gets weirder still. Because if you measure which slit the particle went through, it was either just one or the other. And as soon as you turn that detector on to tell you that, the pattern vanishes. The particle knows you're watching it. Well, welcome to the world of quantum mechanics, a world inhabited by Arizona State University physicist Paul Davies. Paul was born in Finchley, North London, on the 22nd of April 1946. He attended Woodhouse Grammar School and read physics at University College London. From there, his career took him to Cambridge, to Adelaide and Sydney, and latterly Arizona State University. Along the way, he has probed the origins of the universe, the quantum properties of black hole, and even the nature of time. Paul's written dozens of acclaimed science books. He's produced and presented hugely popular programmes for the BBC and other broadcasters, and his contributions to scientific research and communication have also been globally recognised. He's the recipient of the Templeton Prize, which has also been bestowed upon the likes of Mother Teresa, Dame Jane Goodall, and even the Dalai Lama, with whom Paul has worked in the past. And if that's not enough, Paul even has an asteroid named after him. I'm with him now at the BBC's new broadcasting house in London, not far from where it all began. Welcome to Titans of Science.
Thank you very much. It's a pleasure to be back in London, where I come from.
Well, tell us a bit about that intro and getting into science then. How did the story begin?
Very simple. It began in Charing Cross Hospital. I was born a physicist. I never wanted to do anything else. As a child, I was always fascinated by things unseen, looking up at the sky and imagining what might lie beyond what I could see, and then invisible fields, and, anything that was sort of outside of the everyday experience fascinated me. And I suppose that's one reason I became interested in quantum physics. We can't see the weird goings-on down at the atomic level.
Who lured you into the quantum realm, though? When you started getting into science at a higher level, usually when you talk to scientists, there's somebody that really pulled them in. So who was that then for you?
I don't think there was a specific lecturer at University College London. We, of course, had to learn quantum mechanics, I think, in years 2 and 3. I found it inspirational but mystifying. It took a while to wrap my head around it, but I finally did, and it really became an important part of my research.
Niels Bohr allegedly said, if you're not baffled by it, you didn't understand it.
Well, quantum mechanics is one of these peculiar things that it's the most successful scientific theory in history. And so it explains so much. In fact, the nature of matter all the way from subatomic